Hello, in this lecture we find out the area of a circle using two different methods. In the drawing we have a circle and we have also a square ABCD. Square ABCD, that's the circle at this point P and also at this point. And here side BC of square ABCD is tangent to the circle at point Q. And side AB of square ABCD is tangent to the circle at this point. So we'll find the point of tendency of tangent AB with this circle. This point is point S. And we'll also define the center of this circle. This point is point O. We know that all the angles inside any sphere are right angles. So those four angles, they are all right angles. So actually this is a right angle. This is also a right angle. This is a right angle. And finally, and then this is also a right angle. In the next step, we will join points O and S together by straight line. Line segment OS is of course the radius of the circle. We'll define the radius of the circle as x, therefore OS equals to x. So here you can implement rule 1. So I repeat quickly rule 1. According to rule 1, a tangent for a circle is perpendicular to the radius drawn to its point of tendency. In the drawing we have a circle, and this is tangent AB, that is tangent to this circle at point M. Point M is the point of tendency of tangent AB with this circle. In addition, we have also the radius OM that is equals to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule 1. So we can actually implement rule 1 in our drawing. Why? Because in our drawing, we have the radius OS that is equal to x. The radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO according to rule 1. If AB is perpendicular to SO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. In the next step, we join points O and Q together by straight line. Line segment OQ is of course the radius of this circle. Is equal to x. Here you can implement rule 1 because of the fact that the radius OQ that is equal to x. The radius OQ is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever your radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum rule 1. So inside quadrangle SOQB, inside this quadrangle SOQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth preceding angle, in total the must equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this coefficient must be equal to 90 degrees in its sides. So inside the small quadrilateral SOQB, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be at this rectangle, not a square. So we write quadrilateral SOQB is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle SOQB, side SO must be equal to the opposite side QB. But SO is X, therefore QB must also equal to X units in its name. Likewise, according to the same rule, in the same rectangle SOQB, side OQ must be equal to the opposite side SB. But OQ is X, therefore SB must be also equal to X units in its name. So if we found out that quadrilateral SOQB is not a rectangle but a square, why? Because of the fact that all of its sides are equal to each other. Each side of this square is equal to X units in its name. Okay, so we also know that all the sides of a square are equal to each other. So in square ABCD, side AB equals to side BC equals to side CD equals to side DA. And especially side AB equals to side BC. So in square ABCD, side AB equals to side BC. AB equals to AS plus SB. Again, AB equals to AS plus SB. And BC equals to BQ plus QC. So in total, according to equation 1, we found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is. Plus SB. SB is X. And this equals to BQ. BQ is also X. Plus QC. QC equals to 3 units in its length according to what is given us in the question. In total, according to equation 1, we actually found out that AS plus X equals to X plus 3. Here we subtract X from this equation, equation 1. So X will get cancelled. And we left only with AS, which equals to 3 units in its length. So if we found out that the missing 970 AS equals to 3 units in its length. This is the missing 970 AS, which is equals to 3 units in its length. In the next step, we will do a construction. This is to say, from this point P, we will do a perpendicular on the radius SO. Again, from point P, we will do a perpendicular on the radius SO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and SO. This point is point N. When doing this construction, we can do quadrilateral AP and S. Inside this quadrilateral AP and S, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this coefficient angle, in total they must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth cylinder must be equal to 90 degrees in size. So inside the small quadrilateral AP and S we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle, not a square. So we remember quadrilateral AP and S as a rectangle because it has 4 right angles. So write it down. This is quadrilateral AP and S, that is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle AP and S, side AB must be equal to the opposite side NS. But AP is 1, therefore NS must be also equal to 1 unit in its length. Likewise, according to the sum rule, in the sum rectangle AP and S, side AS must be equal to the opposite side NP. But AS is 3, therefore NP must be also equal to 3 units in its length. What is the length of the missing line segment NO? From the drawing it is very easy to see that NO equals to SO minus SN. So I write it down. NO equals to SO minus SN. So in total NO equals to SO. SO is the radius of the circle that equals to X. Minus Sn. Sn is 1. So in total, NO equals to X minus 1 unit in its length. This is 9/7 NO, that is equal to X minus 1 unit in its length. In the next step, we join points P and O together by straight line. So actually 9/7 PO is the radius of this circle that is equal to X. So in the next step I'll copy the right green triangle P and O in a new page and we'll implement the Pythagoras theorem on this right green triangle P and O. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is a progression for Pythagoras theorem. So actually this is the right green triangle P and O that I copied from the original drawing. According to the Pythagoras theorem, it is right triangle P and O, PO squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. So I write it down. So PO squared, that is the square of the hypotenuse, equals to Pn squared plus No squared. PO is x, therefore PO squared is x squared, and it is equals to Pn squared. Pn is 3, therefore Pn squared is 3 squared, that is 9, plus No squared. No is x minus 1, therefore No squared is x minus 1 squared. So in total, if we found out that x squared equals to 9 plus x minus 1 squared. So x squared equals to 9 plus x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared, that is 1, minus 2 times x times 1 is minus 2x. So here we have x squared on both sides of the equation, so x squared will get cancelled. After we cancelled x squared, in this side of the equation we left with nothing, that is to say 0. On the other side of the equation we have 9 plus 1, that is 10, minus 2x. So in total we found out that 0 equals to 10 minus 2x. Here we add 2x to this equation. And finally we get that 2x equals to 10. So here we divide this equation by 2. And finally we get that x equals to 10 over 2, that is 5. So if we found out that the length of the approach PO, that is x, equals to 5 units in its length. But x also is the radius of this circle, so if we found out that the radius of this circle equals to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. Repeat again, the area of any circle equals to pi times the radius of the circle squared, and therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So in total the area of our circle must be equal to pi x squared. So it is pi, x is 5, so x squared is 5 squared. So the area of our circle must be equal to pi times 5 squared. That is to say, it is pi times 5 squared. Pi times 5 squared. 5 squared is 25, so in total we found out that the area that we are looking for in this question, that is the area of this circle, equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. And that is the answer to the question. So repeat again, we found out that the area of this circle equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. So finish with the first method. In the next step, I will present to you how to find out the area of this circle according to the second method. So first of all, we know that all the angles inside any square are right angles. So those two angles are all right angles. So okay, this is a right angle. This is also a right angle. This is a right angle. And finally, this is also a right angle. In the next step, we'll define the center of this circle. This point is point O. And we'll define the point of tendency of tangent AB. This tangent AB with this circle. This point is point S. In the next step, we focus on this point B. Point B is defined as a common external point in relation to this circle. Why? Because point B is not located inside the circle, nor on the circle itself, but it is located outside of the circle. Therefore, it is defined as a common external point, point B. from the common standpoint, point B, we have two tangents to this circle, tangent BS and tangent BQ. And according to rule 2, they are equal to each other. So I pick quickly on rule 2. According to rule 2, the lengths of two tangents from the common standpoint per circle are equal. In the domain, we have a circle, and this is the common standpoint, point P. From this common standpoint, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB, or the length of tangent PA equals to the length of tangent PB. So I can actually implement rule 2 in our drawing. Why? Because in our drawing, we have the common standpoint, point B. From this common standpoint, point B, we have two tangents to this circle, tangent BS and tangent BQ. According to rule 2, they are equal to each other. So I write it down. The length of tangent BS is equal to the length of tangent BQ according to rule 2. So if we define the length of this tangent BS as x, then the length of tangent BQ must be also equal to x, because they are equal to each other in their lengths. Okay, so we also know that all the sides of square ABCD are equal to each other. So side AB equals to side BC equals to side DC equals to side DA. And especially side AB equals to side BC. So in square ABCD, side AB equals to side BC. But side AB equals to AS plus SB. AB equals to AS plus SB, and AB equals to BC. From the drawing, it is very easy to see that side BC equals to BQ plus QC. Side BC equals to BQ plus QC. So in total, according to equation 1, I shall find out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB. SB is X, and it is equal to BQ. BQ is also X, plus QC. QC equals to 3 units in its length, according to what is given us in the question. So in total, according to equation 1, we actually found out that AS plus X equals to X plus 3. So here we subtract X from this equation 1. So X will get cancelled, and we left only with AS is equals to 3 units in its length. So the length of the missing 970 AS is 3 units. The length of this 970 AS is equal to 3 units in its length. In the next step, we'll extend 970 AD by a straight line until it touches the circle. and we will define the touching point of the extended estimate AD with this circle. This point is point M. So, and focus on the current standpoint point A. From this current standpoint, again, point A is a current standpoint in relation to this circle. So, from this current standpoint point A, we have tangent AS that is tangent to this circle, this point S. In addition, from the same current standpoint point A, we have here chord PM. And for that reason, you can implement here all 10. So I click here all 10. All 10 is true in any circle. So in any circle, if AB is any chord in the circle, and PT is a tangent to the circle is point T. So in this way, the following equation is true. That PT square equals to PA times PB. Again, PT square equals to PA times PB. You can definitely implement rule 10 in our drawing. Once in our drawing, if we focus on this current standpoint point A, we have tangent AS that is tangent to this circle, point S. In addition, from the same current standpoint point A, we have here chord PM. That is to say, all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, if you focus on the current standpoint point A, the following equation will be true. That AS square equals to AP times AM. Again, AS square equals to AP times AM. So I write it down. Again, AS square equals to AP times AM. So repeat again. If we focus on the current standpoint point A, according to rule 10, the following equation is true. That AS square equals to AP times AM. This equation is the implementation of rule 10 in our drawing at point A. AS equals to 3 units in itself, according to what is given in the question. Therefore, AS squared is 3 squared, that is 9, and it is equals to AP is 1 times AM. AM in total equals to AP plus PM. So in total, we should find out that according to rule 10, 9 equals to 1 times AP plus PM. So 9 equals to, actually we can ignore 1 because when you multiply anything by 1, you will not change the value of the expression. So you can ignore 1 this equation. So 9 equals to AP is 1 plus PM. PM is the missing side, so we leave it as it is. So here we subtract 1 from this equation, and we get that PM equals to 9 minus 1, that is 8. So we actually found out that the length of this chord PM is equal to 8 units. Okay. In the next step, we will do a construction. That is to say, from this point O, that is the center of the circle, we will go perpendicular on chord PM. Again, from point O, we will go perpendicular on PM, chord PM. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord PM. This point is point M. In conclusion, actually draw perpendicular from the center of the circle, that is to say from point O on chord PM. And for that reason, we can implement here rule 11. So please click on rule 11. According to rule 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. So in the drawing we have a circle. Point O is the center of the circle. From point O, that is the center of the circle, we have here perpendicular ON. That is to say, this angle equals to 90 degrees, and this angle equals to 90 degrees, according to our construction. Actually, perpendicular OM is drawn on chord AB. Again, perpendicular OM is drawn on chord AB. And according to this rule 11, whenever you draw a perpendicular that is drawn from the center of the circle, that is to say point O, the perpendicular also bisects the chord. That is to say, perpendicular OM bisects chord AB. That is to say, perpendicular OM divides chord AB into two halves. Each half equals to AB over 2. So the first half is AM, is equal to AB over 2. The second half is MB, it is also equal to AB over 2. So according to this rule 11, whenever you draw a perpendicular from the center of the circle towards any chord, then the perpendicular will bisect the chord. Here, perpendicular OM, that is drawn from the center of the circle, that is to say from point O, bisects chord AB. That is to say, it divides chord AB into two halves. The first half is AM, and is equals to the second half, that is MB. Each half equals to AB over 2. Again, according to rule 11, AM equals to MB equals to AB over 2. Again, whenever you draw a perpendicular from the center of the circle towards any chord, according to this rule 11, the perpendicular will bisect the chord. So we can definitely implement rule 11 in our drawing. Because in our drawing, we have from the center of the circle, that is to say from this point O, we have perpendicular ON on chord PM. Again, from the center of the circle, that is to say from point O, we have here perpendicular on chord PM. So all the requirements of rule 11 are satisfied, and therefore we can implement here rule 11. According to rule 11, the perpendicular ON bisects chord PM. Again, according to rule 11, the perpendicular ON that is drawn from the center of the circle, that is to say from point O, bisects chord PM. That is to say, it divides this chord PM into two halves. Each half equals to PM over 2. So the first half is PN, is equals to PM over 2, and the second half is NO, that is also equals to PM over 2. So I write it down. So according to rule 11, perpendicular on bisect 4 pm. So the first half is Pn, and it of course equals to the second half, that is Nm, and each half equals to Pm over 2. So according to rule 11, perpendicular on bisect chord Pm into 2 halves. So the first half is Pn, and it of course equals to the second half, that is Nm, and each half equals to Pm over 2. But Pm equals to 8. Therefore Pm over 2 is 8 over 2, that is 4. So as you know, Pm is 8, so Pm over 2 is 8 over 2, that is 4. So from this equation, we derive that Pn equals to 4 units in its length. Yeah, Pn equals to 4 units in its length. Pn equals to 4 units in its length. So this is line segment Pn that equals to 4 units in its length, according to rule 11, of course. In the next step, we join points O and S together by straight line. Line segment OS is of course the radius of this circle, because it starts from point O, that is the center of the circle, and ends at point S, that is the point on the circle itself. So this is exactly the definition of a radius. Therefore OS is the radius of the circle. And because of the fact that the radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle, so whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So inside quadrilateral ANOS, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth incident angle, in total they must be equal to 360 degrees. According to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth incident angle must be equal to 90 degrees in its size. So inside quadrilateral ANOS, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle, not a square. So we know to quadrilateral ANOS is rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So an rectangle ANOS, side AN must be equal to the opposite side OS. But AN in total equals to 4 plus 1, that is 5, therefore OS must be also equal to 5 units in its length. But OS is the radius, therefore the radius of this circle is equal to 5 units in its length. Okay, the radius of the circle equals to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. Okay, again, the area of any circle equals to pi times the radius of the circle squared. And therefore, the area of our circle must be equal to pi times the radius of our circle squared. We just right now found out that the radius of our circle is 5, therefore the radius squared is 5 squared. So in total, the area that we are looking for in this question, that is the area of this circle equals to pi times 5 squared. That is To say it is pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi. In terms of numbers, it is equal to 25 pi is 78.54 square units. So actually, in both methods, we found out the area of this circle, that is the area that we are looking for this question. So in both methods, we found out the area of this circle equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. So in the next step, I will summarize the lecture. We start with the first method. Our mission in this version is to find out the area of this circle. We found out the area of this circle using two different methods. So I'll start with the first method. In the drawing we have a circle, and this is square ABCD. Square ABCD cuts the circle this point P and this point, and side VC of square ABCD is tangent to this circle point Q, and we define the second tangent, the second point of tendency of side AB with this circle. This point is point S. Again, our mission is to find, and we also know that this is line segment AP, that is equals to 1 unit in its length. This is line segment QC, that is equals to 4 units in its length. Again, our mission is to find out the area of this circle. So we define the center of the circle as O. We know that all the angles inside the square are right angles, so those 4 angles are all right angles. In the next step, we join points O and S together by a straight line. OS is the radius of the circle. We define the radius of this circle as x, therefore OS equals to x. Likewise, we join points O and Q together by a straight line. OQ is also the radius of this circle, that is equal to x according to our definition. So here we can implement rule 1. Why? Because we have the radius OS, that is on to point S, that is the point of tendency of tangent AB with this circle. And whenever your radius is 1 to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we have the radius of Q, that is 1 to point Q, that is the point of tendency of tangent BC with this circle. And whenever your radius is 1 to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to the same rule 1. So inside quadrilateral OSBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth incident again. In total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this fourth incident must be equal to 90 degrees in its size. So inside quadrilateral OSBQ, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle plus a square. So we relate to quadrilateral OSBQ as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle OSBQ, side OS must be equal to the opposite side BQ. But OS is x, therefore BQ must be also equal to x units in its length. Likewise, according to the same rule, in the same rectangle OSBQ, side OQ must be equal to the opposite side to the opposite side BS. But OQ is x, therefore BS must be also equals to x units in itself. So we shall find out in total that quadrilateral OSBQ is not a rectangle but a square, why? Because of the fact that all three sides are equal to each other. Each side of this square OSBQ is equal to x units in its length. We know that all the sides of square ABCD are equal to each other. That is to say, side AB equals to side BC equals to side CD equals to side DA. And especially side AB equals to side BC. So in square ABCD, side AB equals to side BC. AB equals to AS plus SB. B and it is equals to BC. BC equals to BQ plus QC. So in total we shall find out that AB is AS plus SB and BC is BQ plus QC. So in total, according to equation 1, we actually found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is. Plus SB, SB is X. BQ is also X, and QC is 3. So in total, we found out that AS plus X equals to X plus 3. Here we subtracted X from this equation 1, so X will get cancelled. And we found out that AS equals to 3 units in its length. This is the missing 97 AS that is equal to 3 units in its length. In the next step, we did the construction, that is to say, from this point P, we do perpendicular on the radius SO. Again, from point P, we do perpendicular on the radius SO. So actually this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and SO. This point is point N. By doing this construction, we can do quadrilateral AP and S. Inside quadrilateral AP and S, we have 1, 2, 3, 1, 2, 1, 2 rectangles. This angle equals to 90 degrees because ABCD is a square. This angle equals to 90 degrees according to rule 1. And this angle equals to 90 degrees according to our construction. So in total, inside the small quadrilateral AP and S, we have 3 rectangles. The sum of 3 rectangles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore this fourth missing angle must be equal to 90 degrees in its size. So inside the small quadrilateral AP and S, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle, if not a square. So we relate to the small quadrilateral AP and S as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So therefore, in rectangle AP and S, so we relate to quadrilateral AP and S as a rectangle. So we know that the opposite side, so AP and S is a rectangle, but we know that the opposite sides of a rectangle are equal to each other. So in rectangle AP and S, side AP equals to the opposite side NS, but AP is 1, therefore NS must be also equal to 1 unit in its length. Likewise, according to the same rule, in the same small rectangle AP and S, side AS must be equal to the opposite side NP, but AS is 3, therefore NP must be also equal to 3 units in its length. What is the length of the missing 97 NO? NO equals to SO minus SN. Again, NO equals to SO minus SN. So NO equals to SO. SO is the radius of the circle that is X minus SN. SN is X. So in total, NO equals to X minus 1 unit in its length. We join, in the next step, we actually join point P and O together by straight line. PO is the radius of the circle that is equals to X. So in the next step, I forward the right triangle P and O in a new page and we implemented the Pythagoras theorem on this right triangle P and O. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Floor 3. This is the right green triangle P and O that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle P and O, PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. the product PO is x, therefore PO square is x squared, and it is equals to Pn squared. Pn is 3, therefore Pn squared is 3 squared, that is 9, plus NO squared. NO is x minus 1, therefore NO squared is x minus 1 squared. So in total, I shall find out that x squared equals to 9 plus x minus 1 squared. Open the brackets of this expression, and finally found out that x squared equals to 9 plus x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared, that is 1, minus 2 times x times 1, that is minus 2x. So this equation we have x squared on both sides of the equation, so x squared will get cancelled. After we cancelled x squared, in this side of the equation we left with nothing, that is to say 0. On the other side of the equation we have 9 plus 1, that is 10. So total, in this side of the equation we have 10 minus 2x, so 10 minus 2x equals to 0. Here we add 2x to this equation and find out that 2x equals to 10. Here we divided this equation by 2 and find out that x equals to 5 minutes in its length. So x is the length of the hypotenuse AO, that is equal to 5 minutes in its length, and x is also the radius of this circle, so the radius of this circle equals to 5 units. Our mission is to find out the area of this circle. Actually, the area of any circle equals to pi times the radius of the circle squared. And therefore, the area of our circle must be equal to pi times the radius of our circle, that is x squared. So the area of our circle in total must be equal to pi x squared. But x is 5, therefore x squared is 5 squared. So in total, the area of our circle must be equal to pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi. So in total we shall find out that we are looking for in this question. The area of this circle equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. We finish with the first method. In the next step I presented to you how to find out the area of this circle according to the second method. So first of all, we know that all the angles inside square ABC are right angles, so all those 4 angles are right angles. We define the center of this circle, this point as point O. We define the point of tendency of tangent AB with this circle, this point as point S. Then we focus on this current standpoint, point B. From this current standpoint, point B, we have two tangents to this circle, tangent BS and tangent BQ. The following to all two are equal to each other. That is to say BS equals to BQ. Again, BS equals to BQ according to all two. So if we define the length of this tangent BS as x, then the length of tangent BQ must be also equal to x because they are equal to each other. Okay. We know that ABCD is a square and all the sides of any square are equal to each other. So side AB equals, in square ABCD, side AB equals to side BC equals to side CD equals to side DA. And especially side AB equals to side BC. Okay, again, in square ABCD, side AB equals to side BC. AB equals to AS plus SB. Again, AB equals to AS plus SB. And BC equals to BQ plus QC. Again, BC equals to BQ plus QC. So in total, I should find out that according to equation 1, AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is. Plus SB, SB is X, and it is equals to BQ. BQ is also X, and QC is 3. So in total we should find out that according to equation 1, AS plus X equals to X plus 3. Here we substituted X for this equation, equation 1. After we substituted X, we should find out that AS equals to 3 units in its length. So this is 970 AS, this is equals to 3 units in its length. In the next step, we extended side line segment AD by side line until it touches the circle. We define the touching point of the extended line segment AD with this circle. This point is point M. So here, if we focus on the common standpoint point A, from this common standpoint point A, we have tangent AS that is tended to this circle and this point S. In addition, from the same common standpoint point A, we have here chord PM. So all the requirements for rule 10 are satisfied, and therefore according to rule 10, we get that AS square equals to AP times AM. Again, AS square equals to AP times AM. Okay, again, according to rule 10, if we focus on the common standpoint point A, AS square equals to AP times AM. AS is 3, therefore AS squared is 3 squared, that is 9, and it is equals to AP is 1 times AM. AM is AP plus PM. Again, AP is 1 and AM is AP plus PM. So in total, we have found out that 9 equals to AP plus PM. AP is 1, substitute AP by 1. So in total, 9 equals to 1 plus PM. We have subtracted 1 from this equation, and I found out that PM equals to 9 minus 1, that is 8. So actually, this is called PM, that is equal to 9 units in its length. In the next step, we did a construction, that is to say, from this point O, that is the center of the circle, we do perpendicular on chord PM. Again, from point O, we do perpendicular on chord PM. So actually this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord PM. This point is point N. And because of the fact that from the center of this circle, that is to say from point O, we have perpendicular ON on chord PM. So whenever you draw a perpendicular from the center of the circle towards any chord, you can implement rule 11. According to rule 11, the perpendicular ON bisects chord PM. Again, perpendicular ON, that is on from the center of the circle, that is to say from point O, bisects chord PM. So, perpendicular ON divides chord PM into two halves. Each half equals to PM over 2. The first half is PN, and it is of course equals to the second half, that is NM, and each half equals to PM over 2. So according to rule 11, perpendicular ON bisects chord PM into two halves. The first half is PN, and it is equals to the second half, that is NM, and each half equals to PM over 2. So Pn equals to Mn equals to Pm over 2. Pm is 8, therefore Pm over 2 is 8 over 2, this is 4. So in total, I should have found out that Pn equals to 4. Pn equals to 4. So okay, this is 97 Pn. That is equals to 4 units in its length. In the next step, you join points O and S together by a straight line. OS is of course the radius of this circle, because it starts from point O, that is the center of the circle, and S and point S, that is the point on the circle itself. So this is exactly the definition of a radius. Therefore OS is the radius of the circle. So here you can implement all 1. 1, because we have the radius OS, that is 1 to point S, that is the point of tendency of tangent AB with this circle. And whenever your radius is 1 to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So inside quadrilateral ANOS, we have 1, 2, 3 integers. The sum of 3 integers is 270 degrees, so 270 degrees plus the size of this fourth incident angle, in total they must be equal to 360 degrees according to the rule. that states that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore this 450 degree must be equal to 90 degrees in side. So inside quadrilateral ANOS we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this right angle plus a square. So we are going to quadrilateral ANOS is a right angle because it has 4 right angles. But we also know that the opposite sides of a right angle are equal to each other. So in right angle ANOS, side AN must be equal to the opposite side OS. But AN in total equals to 4 plus 1, that is 5, therefore OS must be also equal to 5 units in its length. OS is the radius. That is to say that we found out that the radius of this circle equals to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle equals to pi times the radius of the circle squared. So again, the area of any circle equals to pi times the radius of the circle squared. Therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is 5, therefore the radius squared is 5 squared. So in total, the area of our circle must be equal to pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi. So in conclusion, in both methods we actually found out that the area of this circle equals to either 25 pi square units, or in terms of numbers, the area of this circle equals to 78.54 square units. Okay, thank you very much.